Welcome to Wiring Methods, lab number 5. Today we're going to be talking about three-way switches and how they work in a circuit. So in a simple circuit, we have our power source, we have our hot wire, which is the only one we break, our black wire, that's the one we break. We put a switch in. At the end, we have a light bulb, and then we come back to our source with an unbroken neutral. So with a three-way switch, we are going to continue to only break the hot. Like your white wire is not getting attached to any of these switches. Your neutral is not going to be attached to these switches. If you're attaching your neutral to one of the screws on your switches, you've already done the project wrong. So it is going to require an extra wire for us to be able to do this. So we still have our power source, right? This is our home run. Our power is coming in, and then we're going to have a three-way switch instead of a regular switch. And a three-way switch is going to have a common screw, and then it's going to have a pair of traveler screws. So that is our first switch. And in a three-way switch system, we're actually going to have two switches. We'll have a second one, which also has a set of travelers and a common. Now, if you'll notice that I have flipped the direction of those two switches, and the reason for that is because our traveler wires go between our travelers, and our common screw is going to be attached either to the power side or the load side. So one of the common screws here is attached to our battery side, and then we have our switch here, and we're going to connect our common screw terminals. And then we will have another wire in the cable, a red wire, that's going to connect our other travelers. Then we have the switch itself and our load, our light bulb, whatever we're turning on. And now our neutral, sorry about that, our neutral, which is going to return to the source. All right, so now the way that the three-way switches work, if power is applied, we have our power, it comes to this first switch, and we get to, if it's flipped this way, our power goes down the red wire, and then if the switch is flipped to that side, then power can continue on to our bulb and then finish out back to our source. Now, if this switch is in the other position, right? If we flip that switch, it's in the other position. Now the power comes through this switch, right? It's always going through the first switch, one way or the other. And it gets to the second switch, it can't go any farther. That switch is broken, right? Now, at this point, if either switch is flipped, we're going to continue power through the system. That's the beauty of a pair of three-way switches that are wired properly, is that it doesn't matter which switch we flip. It's always going to turn it on or off. Whichever one it is, it's going to do the absolutely opposite. So if I flip this switch on, now I have a path for my electricity to flow. If I go back and instead flip this switch on, then electricity can flow through that path. And this is exactly how the three-way switches that we're going to deal with work. All that we will be doing, the only difference in what we'll be doing is the switches, instead of being in a horizontal position like these are, right? We're gonna flip those vertically into our system. So here I've pulled up our schematic from this week's lab. As you can see, we have a home run with a three-way switch, a 3-wire cable running to another 3-way switch, and then we're going to have although it shows a 3-wire cable going up to our light, we'll only need a 2-wire cable going up to our light from the second switch. So let's draw that. Let's draw that in. Right, we're going to have cable coming into our first switch. We're going to have a cable coming from our first switch to our second switch, and we're going to have a piece of cable going from our second switch to our light. This first cable is going to have a hot wire and a neutral and a ground. We're going to come back and draw the ground in at the end because it's not going to affect how we wire this. It's just bonding everything together at the end, and I don't want those extra lines here to confuse us. I want to make it as simple as possible. All right, so the first thing that we're going to note is that our white wire, it is going all the way through the light. We are not touching the white wire. The white wire remains unbroken from one end to the other, so we're going to bring it down here and tie it together with a wire nut at our first box. Now, our power coming in will be attached to the common screw, right? The common screw, which the common screw is the one down by itself. The two travelers are across from each other, right? So it's the common screw isn't the one that's on one side by itself. The common screw is the one that does not have one across from it. The one that has the two that are across from each other are our travelers. Those are the ones that we're going to use to travel to the other side. Okay, so that's all the wires coming out of our home run, except for the ground we'll get to later. And so now we're going to tie in our hot wire from our other cable. We have our other cable here that has a hot wire, and it's going to come up and attach to our traveler screw. We call this the traveler because it's traveling between the two switches. Now we have a third wire in this piece of cable that would be a red wire, and it is going to attach to the other traveler. Now we come to our second switch box. We're going to do the same thing with our neutral. Our neutral just is in there in the box. It gets tied together with the neutral that is leaving to the other box. That's the end of what we're going to do with the neutral. Just tying it together to get it to the light. We're going to take our hot wire, which is a traveler. It's not always hot, depends on which way the switch is, right? It's one of our travelers. Our black traveler will tie to one of the traveler screws. It doesn't matter which one, it just needs to attach to one of the two traveler screws. Our red wire, our other traveler, will attach to our other traveler screw. And then our third screw, our common screw, remember the common is either going to attach to our home run, which is going to power, or to our load. So this one is going to be the one that comes down and goes into the cable to our load. And so in our final box, our power wire comes up to the black wire on the light, and our neutral wire will get tied in to the neutral wire on our light, and those will get tied in with a couple of wire nuts. And that's all there is to a three-way switch circuit. It's very, very, it is simple. if you just have to think about it for a minute, we always have to have a path for electricity to flow. And so the three-way switches are giving us a way to manipulate that with a pair of switches that can be turned on or off to give us control of a light from two separate sources. The last thing that I would do would be coming in and attaching all of my grounds. This is actually the first thing that I would do. If you know, when you're coming to your box, is tie all your grounds together. That's really the first thing that you should be doing. Just coming in and tying all your grounds together and tying them to our receptacles. That's all there is to lab number 5. You can take a look at the lab 5 wiring video, which will actually show us wiring it all up.